Good day. Thank you for joining our webinar today. I want to be mindful of everyone's time. I know it's right now 11:01, so want to get things kicked off and moving. We will be recording this session and we'll be making it available to you. We will also have a couple of questions that will be in between presenters. So please take a moment and respond. It would be greatly appreciated. The questions will be only up for just a quick moment, so they're not going to be up for a long period of time. So be very expedient in your answers, please. In addition, please submit your questions in the drop-down question box, and we'll be trying to answer questions as they're received. And if you hold them until the Q&A session, just realize that we are answering the questions as they're coming in. And so if we run out of time, we will be getting answers out to everyone after the webinar. So today, why and how to go multi-primary over regular replication is our title. And we will be starting with Colin Charles, who is the Chief Evangelist for Codaship. And he will be covering the Galera clusters. And wrapping up will be Patrick O'Halloran, who is our Senior Sales Engineer for IDERA. So Colin, I'm turn it over to you.
Okay. Yes, thank you. So does everybody see the screen just fine?
Not yet. There it comes.
So I'm going to talk to you a little bit about. So I'm going to talk to you a little bit about why and how you would probably go multi-primary or multi-master over regular replication. And I'm Colin Charles, as was stated earlier. I have the MySQL here at Codaship to give you a little overview. So the overall agenda is Codaship. Then I'll talk to you a little bit about the types of replication available in MySQL as well as MariaDB. I'm going to talk about multi-primary, also known as multi-master replication. And these terms can be used interchangeably because occasionally some people, of course, multi-master is the term that's been used in database worlds for decades, but maybe some people take offense to the term of master. So we're going to interchange between multi-master, multi-primary, and so forth. So we can talk a little bit about migration strategies, thoughts that you have to remember when you're going to basically migrate your application or even write an application, and then also a little bit about monitoring. So of course, after that, we're going to get Patrick to give you a lot more about monitoring from what IDERA offers as well. So Codaship, basically, we always refer to the company Codaship as the developers and experts in Galera Cluster. The company's been around since 2007, so it's over a decade. It's a three-founder company, full-on engineering from the CEO, CTO to the architect. It operates a services business model, producing 100% open source software, so no open core, no funky license. It's all GPL software that attaches very well to MySQL. It is wide used, very well tested software in different kinds of applications, especially applications that cannot tolerate downtime, data loss, lost transactions, all with ease of use as well. It's important to remember that we have thousands of users in various industries, all the way from e-commerce to telcos to banks, education, software as a service, PaaS platforms, infrastructure as a service platforms, and so on. So let me sort of get started with what kinds of replication is available in the MySQL, MariaDB world, and also I'm going to use those two servers interchangeably because MariaDB is basically a fork of MySQL, but when it comes to replication, many things are kind of similar. Uh, Not all are similar, but kind of. So from a high level, you have asynchronous replication, where you make an insert and it gets written automatically to the server you've connected to, which is the primary. And then it is very fast because it just inserts into the primary and then you can keep on inserting over and over again. It tends to be very fast, but it does not give you any guarantee that any secondary could receive the transaction. And sometimes the secondaries have what is known as secondary lag or slave lag. So you can actually see this from show slave status in MySQL. And you can see that if you have your primary in one data center and a secondary in another data center and it's doing a lot of load, it may be delayed sometimes by seconds, minutes, hours, and that's not something that many people enjoy. And you also need a framework to handle automatic failovers, just like semi-synchronous replication, which brings us to what is semi-synchronous replication in the sense that you will insert your data it will reach your master and at least one secondary has to receive said transaction in the event that you lose the primary in any given way, shape, or form, you can actually, with the automatic framework, basically promote the most current secondary to be the new master and have the others basically read off be slaves of the new master. So in the event that you insert to a master and secondary one is the one that has the most current, you could actually kill the primary. Secondary one gets promoted to the primary, and then secondary two and three read off secondary one. And then there's also, of course, the idea of a virtually synchronous Galera cluster. And this is basically where when you make an insert, there is no idea of a master or a slave or a primary or a secondary. Every node is equal because basically with multi-master replication, all nodes contain the same data. There is no framework that you need to handle the failure because it's built right into the solution that is available for you. And this, I think, is extremely powerful. Naturally, it is well worth noting that this is not the only solution out there in the MySQL space. There is something called in the cluster group replication, but of course today here we are here to talk about Galera. So when it comes to replication frameworks, it is very important to also remember there is no built-in method for automatic failovers inside of MySQL to ensure high availability when you're using asynchronous or semi-synchronous replication. This is why you have to use third-party frameworks like MHA, Replication Manager, Orchestrator, and a whole bunch of other tools um, like PRM and so forth. And of course, to use a failover framework, it is best to always use semi-synchronous replication. And in MySQL, semi-sync is a plugin, but MariaDB Server has it built in. Sometimes people also end up using a proxy to load balance or round robin reads, writes between primaries and secondaries to ensure that there is no conflict. This is all the complexity that you would require when you are using asynchronous or semi-synchronous replication framework. So that brings us down to synchronous multi-master clusters. And Wikipedia actually tells you flat out that a multi-master replication is a method of database replication which allows the data to be stored by a group of computers, so basically many nodes, and updated by any member of the group, which means that your application can connect, if you have a 3-node minimum, you can connect to any of the 3 nodes and basically insert or update data. All the members are responsive to client data queries. And of course, the multi-master system is responsible for propagating the data made by each member to the rest of the group. So this is what happens with the write set replication that's available in Galera Cluster. It also resolves any conflicts that may arise. So Galera uses optimistic concurrency control made by the different members. So the advantages, are clear. If a master fails, the other masters continue to update the database because all the nodes are equal. You also have distributed access, so you can have nodes in several data centers, and it's distributed across the network. Of course, Galera is also extremely highly consistent. so it doesn't violate ACID properties, which is a huge bonus of using Galera. Performance. Naturally, yes, I already told you earlier that asynchronous replication would be the fastest. Semi-synchronous, because it has to write to at least one slave, would be a little slower. And Galera, as long as it's writing within the same data center, would be a little slower because it's writing the same data to, say, three copies of three different nodes. And then, of course, integrity, again, as I said, Galera ensures integrity of your data. So basically, multi-master replication, the panacea for it is to increase availability, to ensure you have good server response time and you never have downtime. It's all about high availability. So so does multi-master solve everything? Basically, if you want to have read-write queries that are not affected by limited bandwidth, you're using it over a WAN with maybe elevated latency over such links like you're trying to replicate between Rackspace Cloud and Google Cloud and Amazon. Multi-master like Galera could potentially solve that problem for you. You also never want to have any writes on a master to be visible much later on a secondary standby. You don't want to have replication delay. You want to have all nodes to be current. You want to make sure that clients, if a secondary site loses write access to the WAN link, is disrupted, clients can continue working. You also want to never have the problem of a split brain and two active but separate different masters, because you want to make sure that your framework handles the ability to shoot the other node in the head. That's what stoned means. And of course, you really want to ensure that node divergence would automatically resolve once the network returns without manual repair and resynchronization. And Galera can actually do this if you set the size of the Gcache to be large enough and the downtime wasn't long enough. And there's a calculation for this to ensure that you sit in a good window where there doesn't have to be a re-imaging of pulling in a whole backup, and it sort of automatically will repair itself. So I would say it's not a panacea for everything. I'd say you look at Multimaster as another tool. It solves many problems, but you will have to require some additional design constraints and thought process. You deploy it when it will solve your problem, and Galera will provide for shared nothing storage. That doesn't means you don't need to use a SAN or shared disk in any form. It provides ACID consistency. It doesn't have geographical limitations. It will actually prevent data conflicts. It's virtually synchronous commits across all nodes and generally transparent to the application, which means that it's fairly easy to migrate from an existing application to Galera cluster generally. So Galera is basically a generic replication plugin for database servers. It uses the replication API to interact with the database management service via the write-set replication API project, which, as I said earlier, is all fully open source on GitHub. It doesn't make any other modifications, and of course, it's very important to remember the database and the Galera plugin must have the same WSRep API version. So if you want to make sure all your nodes are equal, and of course, Galera's performance is also such that as long as it's writing to all nodes that are equal, it'll be performing as fast as the slowest node. So Galera cluster comes in various distributions, and it's really well distributed. So MariaDB has included it since 10.1, had built in, and MariaDB is over 12 million downloads as of March 2017. So the download numbers have gone up. ProtonX DB cluster is over 1.3 million downloads. So we have so much more from GaleraCluster.com, and we never count the distributions, Linux distributions, and BSD distributions that include Galera as well. Many cloud platforms like OpenStack recommend Galera Cluster, and it also won a MySQL Community Award of the Year. So in a nutshell, Galera Cluster multi-master application ensures that your application basically looks at one very large database with multiple entry points. Transactions are processed locally until commit time, then replicated across all nodes to the whole cluster. It is fully synchronous, such that each transaction is immediately replicated on all nodes during commit and get certified. There's no sales slaves, and that is why we say virtually synchronous. It's got multi-master support, where you can read from and write to any node. It has automatic transaction conflict detection and resolution. You can think of it as basically replication, where a copy of the entire dataset is available on all nodes. New nodes can join automatically. It has data consistency protections to avoid reading stale data and also preventing unsafe data modifications. It works across wide area networks, So nodes can be on different continents. It has end-to-end encryption available. It's optimized communication with the least latency, and it's obviously InnoDB only. So Galera cluster, in sort of a conclusion, is it's such that it's very highly scalable. It is you can add delete nodes on the fly. Uh, you can, it's got quorum-based failure handling, which is why we need a minimum of 3 nodes. So don't assume you can get high availability with just 2. 3 nodes means that if 1 node goes down, there are still 2/3 of the cluster around, and that's what quorum-based failure handling is. Optimistic concurrency control is such that when a transaction is brought in on node 1, when it's time to commit, it starts applying across node 2 and node 3, and only when it's applied across all does the client get the OK packet from node 1. And of course, all nodes are equal. This is not something where you need some kind of auto failover framework. This is built into Galera. There is parallel replication support such that any number of slave apply threads can be started, and slave control is at a row-based level, so it applies in parallel, with commit order being dictated. And I'd really like to tell you again, no frameworks are required. Fully optimized for the cloud, because not only is it optimized network protocol, so if you have 3 data centers, you segment your Galera clusters to ensure that you're only writing to the relevant segment where your application is, and then it writes to 2 other elected nodes inside the via the WAN. So in a 9-node 3 data center Galera cluster, you only write 5 times, not 9 times. And that's really how we have topology aware replication via segmentation. And if for some reason you have unreliable nodes and unreliable network, Galera will evict due to network flaps or node failure. And if it keeps on being evicted, it will not be able to rejoin without manual intervention. And by default, it comes with split brain recovery as well as management, and it's key to encrypt your traffic when you're using the cloud. So just to get away from a few confusions, you can get Galera cluster from galeracluster.com. You can also get it from MariaDB, and they have 10.4, which is generally available now with Galera Cluster 4, released just last week. We of course work very closely with MariaDB Corporation, and they are a trusted partner. And of course, there's also a separate download available as Percona XDB cluster. So 3 different branches, and of course, if you follow the upstream, which is the one we provide, you get MySQL there from there as well. So a few feature highlights. We provide the ability to have intelligent donor selection. So prefer a donor that can do incremental state transfer instead of a full state snapshot transfer. This is extremely important to ensure that you recover quickly. When the cluster does crash, say via a power failure or something, all nodes maintain the cluster information persistently, so you don't need to bootstrap and restart the cluster. Streaming replication is in Galera 4, which it replicates transactions of any size, so anything larger than 2 gigabytes basically get chunked into segments and then replicated with certification as well. There's also a consistency voting protocol so that all nodes vote when such inconsistency is detected. And soon to come in MySQL 8 with Galera 4 is DDL optimization, so locks only apply to an affected table. You can make changes without locking your entire cluster. A migration is extremely simple. If you already have an existing Masterslave setup, it's fairly easy to convert an existing setup to Galera just by building up the cluster to the desired size, switch the readers over to read from the new cluster, then you switch the writers to write to the cluster, and then you deactivate the async replication altogether, which also means that Galera works with fully synchronous replication as well as asynchronous replication on the same exact node. So this is a quick example of how that would happen. You'd write currently async master to a bunch of slaves, and then you can also read. Then you can migrate fairly quickly to and switch to a fully multi-master cluster. There are some application thoughts that one would have to think about, and we're going to have to spend a little bit of time on this. This is not necessarily the full entire list of the application thoughts one would have, but you have to make sure that with Galera, all tables have a primary key. Yes, Galera could probably replicate without a primary key, but it's the most interesting way to find problems. It's also good practice to ensure you have a primary key, because yes, InnoDB does assign an internal primary key, 6 bytes long for every row. So it's much better when you have a primary key. So enforce the primary key. You have to only use InnoDB as a storage engine. So if you check out something like MariaDB, you'll see that they have many cool engines like MyRocks and a whole bunch of others. And none of them actually work alongside Galera Cluster. So it has to be backed by the default storage engine, which is InnoDB. You also have to make sure that your application does not require distributed transaction support. So if you need the XA protocol, this is a feature coming in Galera in the very near future. This is not available at the moment. If your application starts using things like locked tables, unlocked tables, get lock functions in MySQL 5.7, and so forth, those are not supported as well. You cannot lock a table on one node and expect it to replicate to the other nodes as well. The one thing that I really have to make sure you focus on is to ensure that you have to beware of high concurrency hot rows. Basically, a high concurrency hot row is in the database is when you have a lot of updates of the same exact row, and this will require you to set the option inside your my.cnf wsrep retry auto commit something to a value like 5, for example, which means that and also set the application such that it knows that can be a delay. And this retry auto commits basically means that if during the time it's time to apply to other nodes, and it cannot apply because of some kind of conflict, it will retry the commit before it returns back to the client that it has failed. So if you set it to 5, it will retry 5 times. Remember that 2 transactions writing to the same row and committing to separate nodes means only one can successfully commit because of optimistic concurrency control. So you will get an abort or a deadlock, and you will need to retry the transaction. And it's so much better when the application doesn't have to retry it, and we can let the Galera engine retry it for you. And if it retries, say, if you set retry auto commit to 5 and it has failed after 5 times, only then does the application have to acknowledge that there was a failure. And I think that's quite important, because a lot of people have applications timeout even maybe after a very short period of time. You set the retry auto commit to be large, make sure that your application timeouts are also lengthy. Also, if you happen to write applications that control MySQL users, remember that you cannot do an insert user into MySQL user table for it, because that doesn't work. You have to actually make sure that you're using the create user statement, because that is what is replicated across the cluster. And this is something we find to be a very common mistake many people tend to make. And we cannot, of course, block any of the syntax, but we have to caution you that if you are doing any kind of account management in applications, this is something important. Also, if you're doing schema changes, there are 2 types of schema changes, which is the rolling schema upgrade, the RSU, and the total order isolation mode, TOI. And if you're doing this across the cluster, this requires planning. This is even when you're updating Galera to a new version. And we tend to write very extensive documentation on how you need to upgrade the nodes, uh, upgrade from one node to another and to another, and how you need to also hold writes to the new node so that it can only handle reads first. And then you have to do the second node where it can be upgraded, and then you enable both the nodes to do writes, and then you upgrade the third node for read only. It does require quite a bit of control during upgrades of even the schema, as well as if you're doing a full server upgrade. So this is one of those things that we definitely do right, and highly recommend that you take a good look at the documentation on it. But of course, I think this presentation is meant to be a little bit more high level, so we're not going to cover all of that, obviously. Now, when it comes to monitoring, you obviously have to be able to read the show global status, and then of course there are many GUIs like the ones IDERA offer that allow you to actually grab the global status. Of course, if you run flush status, it'll reset the status log, so don't run flush status liberally. Galera Cluster also reports events via the MySQL server error log. So actually having the error log around and reporting and checking out what it says is also quite important. You also definitely want to monitor each node separately for maximum effect. That really means that if you're using the IDERA tools, make sure you're monitoring 3 nodes, not just one of the 3 nodes in your Galera cluster. It's also important to monitor the health of the network. So round trip times, which is the ping RTT, is useful, the bandwidth utilization, and if you have, say, 3 data centers, it is worth also measuring the network links between any 2 segments. So if you have 3 data centers, let's say between Singapore, Sydney, and London, you want to make sure you measure the links between Sydney and Singapore, as well as Singapore and London and Sydney, and so forth, because those links also totally make a difference in the way Galera can operate. Galera 4 also has 3 new MySQL tables. So in the MySQL table, you can even monitor now your cluster status, there the members in the cluster, as well as the ability to see how streaming replication in Galera 4 is working. Are you actually benefiting from streaming replication? So there are a whole bunch of things that you want to monitor, and I hope this was a good high level overview of how you would migrate to a multi-primary mode, why you may choose it over regular replication. The clear thing here is you choose it because you want high availability. You're willing to have replicas of your data, and you cannot afford any sort of data loss and or downtime. So, with that, I hope you've got a very quick overview in the past 28 minutes. I believe we're soon going to have a poll, and then we're going to go and talk more about monitoring of your Galera cluster.
Hey, Colin,
Thank you.
there is one
Yes.
question in the question box, uh, and it says,
Okay.
and how does the DDL locking work in Caldera 4? Does it prevent all the cluster locking events that exist in Caldera 3 with, and I'm trying to see if I can scroll down just a
Yes.
second.
Uh, that is a good question.
Okay.
Even though you've partially given me the question, yes, Galera 4 actually has the DDL optimizations that prevent you from locking the whole cluster during schema updates, and this would be extremely useful if you were web hosting company and so forth, or just doing lots of schema upgrades. Now, if the next question is, can I use this today? I have to unfortunately disappoint you because yes, while MariaDB 10.4 was GA last week, this feature didn't quite make it into the 10.4 release. This feature is guaranteed to make it into the MySQL 8 with Galera 4 release that we will provide by the end of summer. But as to when it will reach the MariaDB variant, it may come in another point release in 10.4, or it may come within 10.5. But yes, Galera 4, once you get to it, will actually avoid the DDL locks of Galera 3 and before. So it will be a huge improvement for you.
Okay, and we have another one. In Galera documentation, it says a primary key is required. Is it sufficient to have a column with unique constraints or index, or does it always have to be a primary key?
It always has to be a primary key. Like I said, InnoDB does assign one internally for you, and there are many instances where it continues just working, but it is highly recommended you have a primary key, not just unique constraints.
Okay, next question. Why is Galera 4 only available to MariaDB? At the Persona conference, Codaship said they release of MariaDB first, then everyone else later. Doesn't this uh,
Okay.
doesn't this attitude basically cause some issues?
Yeah, hi. So that's also an excellent question. So as I said much earlier, Codaship and MariaDB have a very good working relationship. So we work on the MariaDB base first. We make features available in both releases, and the MariaDB release will come before our MySQL release. We do not have any such relationship with Percona XDB cluster, so it is up to them to port from us once we release the MySQL 8 release. But we're also a generally smallish development team, and we have to prioritize which one gets our developments first. And we made it clear even at the Percona Live conference that once the MariaDB release comes out, it'll be shortly thereafter you'll get the MySQL release, and we, like I said, should be able to have an alpha or a beta out fairly soon. Like I said, MariaDB literally only got released last week, so watch this space. GaleraCluster.com is where we will announce these things, and yeah, this is how it's always been for quite some time in terms of releases. So we just got to pick which server we're going to go for first, and then move on afterwards. And if you feel like you have a requirement, feel free to always email.
Okay. All right. Does Galera require a router such as MySQL router for InnoDB cluster?
DB cluster. So no, Galera does not require a router or a proxy. There are three major proxies in the MySQL world today. That's MySQL router, Proxy SQL, and MariaDB MaxScale. Galera does not require you to have round robin or load balancing routers or proxies, but you can optionally also have a proxy available, and it's entirely up to you, but it is not required.
And next one is if I well understood, Galera 4 is now able to manage a split brain uh, redemption that corrects. Is that correct? Remediation. Sorry,
Galera
brain
4,
split
Galera
brain.
4 as well as 3.6 will be able to handle split brain scenarios as long as you do not misconfigure it. And we do extensively talk about how to configure split brain scenarios, avoiding split brain scenarios inside of the documentation as well. And I maybe should give a shout out to our documentation because in the last 2 weeks it has improved tremendously from what it used to be before.
Okay, and last question. How is the sequence of applying changes is guaranteed when using parallel apply, considering that the changes can be done in two tables linked with foreign key where apply order makes sense? You there, Colin? Did I lose somebody?
I think Colin's gone quiet.
I think I lost Colin.
You stumped him. You stumped him.
I tell you what, on the last question, we will get back to you on that. I apologize.
I can. This is Patrick. I can address some of that. If I'm understanding the question correctly, how are transactions applied in a correct order? Entire transactions. There's a identifier called the global transaction ID that's unique for every transaction, and basically the transactions are numbered in sequence and applied in sequence.
Got it. Okay.
If I'm understanding that question correctly.
No, very good. All right, so let's take just a moment. We're going to do
I don't seem to be able
polling.
to hear you very well.
You can't hear me? Okay, let's go into our polling questions. And here's our first polling question. All right. I'm going to close and do our last polling question. Okay. Thank you, everyone, for participating. And Patrick, are you set up as presenter now?
I will be in just 1 second.
Okay.
Okay, so I'm assuming you can see my screen.
Perfect.
Okay.
It's all yours.
All right. Hey, thank you, Scott, and thank you, Colin. I enjoy these webinars because I always learn something, and Colin did a great job of talking about Galera clusters and why you would use it and how it works and the various advantages over typical replication in MySQL. I also today, for the first time, learned what stoneth means, so I need to use that in a sentence somewhere today. All right, so I've got, my name is Patrick O'Haller, and I'm a sales engineer with IDERA. I'm going to show off a product that is got a very, very long name. The name of the product is SQL Diagnostic Manager for MySQL and MariaDB, but I'll just refer to it as DM for MySQL. Just to understand that it works both with MySQL and MariaDB equally as well. Formerly, it was known as Monyog, developed by a company called WebYog. IDERA acquired WebYog about 14, 15 months ago, and it's been rebranded as DM for MySQL. I've got a PowerPoint presentation I'm going to zip through pretty quickly. This is available as notes afterwards. If you actually look at this, there's quite a few in the speaker's notes, some information here. So if you do look at this PPT PowerPoint presentation a little later, just don't forget to look at the speaker's notes. I want to talk a little bit about what DM for MySQL is, why you'd want to use it, how you can get it, how you can get a free trial, and then how it's going to be used with Galera clustering, in addition to just monitoring MySQL and MariaDB databases. So it's a 24/7 monitoring solution, gathers information using various MySQL commands to get information about sessions and statistics and values and counters and everything else. It's agentless. We're not modifying or changing anything on the databases themselves. It can be up and running in 2 minutes. That's one of the great things that I liked about it when I first saw it, is you can download it and literally the install is under 2 minutes. And that's probably if you take a 1 minute break. And it can monitor both on-premise and cloud instances. There's a lot of versions of MySQL, MariaDB it supports, all the latest versions. I'll talk briefly about the architecture. It's a self-enclosed application that includes an HTML server, a web server, and a historic database built on SQLite. It's reaching out, connecting to various databases, gathering performance data, saving that in the SQLite database. And then when users connect via a browser, it's presenting all the information that's saved over time. That's one of the nice things about it, is that historic database where you can view data not as it exists now, but maybe what happened 5 minutes ago or what happened last weekend. You can go to webyog.com and download it there. As I said, it's a free, fully functional 2-week trial, as well as idera.com. And there's also a website, monyog.com. You can go there. It installs as a wizard. It installs in Linux as a package. Very, very easy install. Installation instructions are available online. That's my spiel on DM for MySQL. And now I want to talk about briefly how you can use it for Galera clustering. And I broke this into 3 sections. What do you want to do before you implement Galera clustering? What do you do to actually monitor it? And then how do you use DM for MySQL when you've actually got a problem and need to fix something that went wrong, if that should ever happen? Basically 4 things, and I'm going to go through a live demo of these, so these slides are going to be pretty brief. A couple things. Check the configuration of each node. As Colin mentioned, the cluster is only as fast as the slowest node. So you want to make sure that you've got the same buffer sizes and blocks and everything else, so that every node is running optimally. You want to ensure, as you said, that NODB is used for all tables. You can use different database engines for different tables. You can have in-memory tables. Maybe you've got an old application that uses ISAM database engine. Maybe I found out this week you can actually write data to CSV files directly, but only NODB works. So you want to check and make sure you're using NODB run the tables. I wrote down yesterday that ensure that all the tables have unique or primary keys. Colin corrected me earlier and said that only primary keys. So you want to make sure that all your tables have primary keys. This is a little information on going through each of those steps. As I said, I'm going to go through a live demo. And then get to the second section, monitoring an active cluster. There's various features and functions within DM for MySQL. There are dashboards, so you can look and see charts over time. There's various monitors that can send notifications if thresholds aren't met or statuses go bad or things like that. I'll talk about those in the online demo. Here's the dashboard. Here's some monitors. I'll talk about some of the features of that when I get to the live demo. And then what do you do when you actually have a problem? Identifying slow nodes, nodes that have been removed, identifying the most advanced nodes. So as transactions are applied, maybe a transaction has been applied to one server and not the others when the cluster breaks. You want to be able to identify where the most advanced node is so you can recover from there and not lose any data. All right, so I'm going to switch to the live demo. So as I said, it's a web-based application, DM for MySQL. So anyone who's got the URL, I'll log out just so you can see what that looks like. So this would be the login page for DM MySQL. You type in your credentials. It comes up looking like this initially. I have a habit of expanding this so you can see the names of the tabs here. And as I do with all demos, the first thing I'll point out is down here the documentation. If you do download this, if you do decide to try this for a trial, the documentation is very, very, very good. I'll just point out that in the documentation under Navigate, we've got these subjects, overview, servers, dashboards, monitors, threads, real-time. That matches exactly what I'm seeing in the GUI, overview, servers, dashboards, monitors, threads, real-time, and so on. So if you do download this, if you do try it, don't forget the documentation. Don't forget that you can read through the documentation in the same sequence that you're going through the things in the GUI. All right, so servers. Defining servers, I mentioned creating tags. I've got 7 servers here, which isn't a whole lot, but we have customers that have as many as 1,200 different servers they're monitoring, and they need some way of organizing them. And the way you can organize them within DM for MySQL is using tags. So tag is just a free-form name. I can apply multiple tags here. I just created a tag called Galera Cluster and applied that to Galera 1, Galera 2, and Galera 3. And you'll see how I use that later. But it could be production, it could be an application name, it could be QA, it could be a data center name, whatever grouping makes sense for you. So now that I'm here looking at the servers, I can click here and say, let me just type in the Galera Cluster tag and or server names, and I can see those. As I'm looking at the dashboard and I want to see these charts relating to certain servers, I can go here. I can first of all deselect everything, select my tag name, and now it shows me the nodes in that, or the servers that have that tag. I can select those. So that brings me here to the dashboard. Dashboard consists of pages. We have a page dedicated to Galera metrics, queue length, transactions, things like that. As with most applications, the dashboard's meant as sort of a high-level view of the health of whatever it is you're monitoring, in this case, the cluster. I can look here and I can see metrics across the nodes. I can graph this out over time. I can also use this after the fact. If something happened, say, as I said, a couple hours ago or yesterday, I can look over a period of days and look and see how these various metrics have changed. Maybe that'll help me identify something in the cluster to identify maybe something that's gone wrong. I can have this on a monitor displayed over a work area with maybe a couple key graphs in it. That way, every time I walk by, I can glance up and just get a real quick view of the health of my cluster. All right, so I was still talking about preparing for implementing the cluster, and there's a couple of things I wanted to talk about, one of which was server configuration. Again, I can use the tags to select servers. This basically goes through all the variables in the configuration, and right now it's just showing me the ones that differ. I want to make sure that these make sense. I don't want to have, like, as I said, different block sizes or different parameters that can make things run differently. So first thing I would do is look at the server configuration, have the various nodes in my potential cluster, which hasn't been started yet, and make sure that they're all configured similarly. Again, the cluster is only as fast as the slowest node. The couple things I would check under monitors, which are alerts. I've got the Galera monitor group selected. If I scroll down to the bottom, I've got presence of non-InnoDB tables. So if there are any tables that are using ISAM or some other database engine other than InnoDB, I'd see a count of those tables here. And then tables without primary unique key. Again, if there's any tables, the write sets, which Colin mentioned, which are used to encapsulate transactions and send data from one server to another, rely on primary keys. And if you don't have those, things can get very, very, very slow. So that's essentially what I would check: the server configuration, non-InnoDB tables, and primary unique keys, as well as putting tags on there. Second thing I want to talk about is monitoring an active cluster. Again, that's dashboards using the Galera page and looking at the various graphs here. Give me indicators on how it's behaving. And monitors here as well. There's a few different monitors that might come in very, very handy. Number of nodes in the cluster. I certainly know what that is. When I set up the cluster, if that changes, I want to be notified. I could be notified via email, via Slack, PagerDuty, SNMP traps. If you have HP OpenView or some other messaging system in your data center. Cluster status is a good one. All these should read primary. If a node goes offline for some reason, I want to be able to identify, be notified by that. A few other things about percent throttled. Where was that one? I think it's up to the top. So basically, the nodes will get the write sets and apply the write sets. Here it is. And if they fall behind for some reason, maybe someone's running a long query, they're doing a huge select or running reports or doing data warehouse applications on one particular node. If one particular node slows down and can't keep up with the write sets, it will actually talk to the other nodes and tell them, hey, stop what you're doing for a little while and let me get caught up. And that's called flow control or throttling. So if throttling goes up, what that tells me is that their nodes aren't able to do anything because there is another slow node somewhere in the cluster that's getting behind on committing write sets. There's a few other things I can look at here on failed transactions, things of that sort, that again give me a good idea on the health of my cluster. Now, should something go wrong, should I be notified either because a node goes offline, or there's a high amount of throttle weight, or a lot of failed transactions, or it may be by application, I'm getting a lot of errors based on transactions failing. There's a few other ones here. I identify the slowest node in the cluster, the one that's causing the most throttling. I can look and see if any nodes have been removed. Various other things I can check here that may help me identify which nodes are misbehaving. Another thing is the most advanced node. This tells me what the highest transaction number, the global transaction ID that each node has written. Right now they're the same, but again, if the cluster failed for some reason, one of these may be higher than the others. What that tells me is that that node has transactions committed that the other nodes don't. So if I were to bring the cluster back and bring these back online, I would want to start with the one that had the highest global transaction ID, because that's going to have the most current data. I'll just take a couple minutes to talk about more features of DM for MySQL. There are a huge number of features here. Colin also mentioned that you don't want to just monitor the cluster, you want to monitor the nodes within the cluster. I can look and see, in addition to statuses of the individual clusters, there are some 600 different out-of-the-box monitors. So if I'm experiencing low cache hit ratios, other problems on a particular node, I can set up alerts around that. I can look and see it historically. If something's happening on a particular node, I can look and see the current threads. I can look and see, monitor what SQL statements are being identified. I've got access to various log files, including the sniffer, which is unique to MySQL. I can essentially trap every single SQL statement that's executing over a period of time and go back and play them back. So there's a huge amount of ability to monitor each of the individual nodes here and troubleshoot what's going on. Let's say node 2 had a problem. I can go here and then say, I've already got it selected, but I would go here and say, okay, show me the nodes here. I can select node 2, and instantly I've got this is a demonstration system. It doesn't have any queries here, but I could see the top queries that are taking the most amount of time. So if Galera 2 were causing other nodes to throttle because of flow control, I could go in here and get a lot of information on what it is it's actually doing. So I encourage you to take a look at webiog.com. I can get here or IDERA.com and try now. Download it, like I said, free, fully functional, 2-week trial. It's good for, as you saw, monitoring Galera, some of the key features of that, as well as just keeping tabs and historic information on MySQL and MariaDB instances, whether they're Galera Cluster or replication or just standalone nodes. All right, so we're coming back up close to the top of the hour. Colin, I've got my questions page up, so if there are any questions, I will be glad to answer them.
Yeah, I guess I just want to make one quick statement with regards to primary keys and unique keys. So, primary key is basically a key in the primary index, and this is with InnoDB, it's a sorted dictionary and so forth, whereas a unique key is some kind of secondary index having some kind of unique constraint. And in InnoDB's case, if you define no primary key, it'll use the first unique key as the clustered index. And Galera does require tables with primary keys because this is important to ensure that rows appear in different order on different nodes in the cluster. They don't appear like that, right? So you want to make sure that when you do select with limits and so forth, they don't return different results. Yeah, and if you of course have a table basically without a primary key, you can later on add an auto increment column to the table without actually breaking your application. So we do have like workarounds for you as well. So yeah, that's all I wanted to say. But I guess this is the MySQL SQLism, the differences between a primary and a unique key, and I just wanted to make that clear. Some people just call a primary key, unique. Okay, yeah. Now you can go back to answering your questions. Thank you.
Okay, thank you, Colin. Scott, I'll turn it over to you.
All right. Let's see if we have some questions here. We are a current user of Manyog DM software. There was always a need to pull some stats from the DM that are related to multi-host parentheses different from GUI available download files. Is there a way to run reports against the SQLite DB to extract the list of monitored hosts and some stats?
Sure. That's a good question. Yes. Let me get into a little more detail. So SQLite, for those of you not familiar with it, is just another database vendor. It's what's used by DM for MySQL, or formerly known as Manyog. There are third-party tools. They're not provided with DM for MySQL, but I've downloaded some. There's even web browser add-ons where you can go view the data. It's basically just stored as in data files. The format, the schema for the data is in the documentation as well. That's well published. If you have any specific questions that maybe the documentation doesn't answer, feel free to contact me or your sales rep, and I'll be glad to get you any more details you need.
All right. Next question. You've mentioned that most advanced node can be used in case of a cluster crashed based on your practice. I guess how often it happens for clusters to crash. How to be proactive.
I'll let Colin answer that, but basically my response would be very, very rarely. You may have individual nodes that fall off for various reasons, because they're slow, because you can actually get kicked out of the cluster for being too slow. But as far as the whole cluster breaking, Colin, do you have any practical experience or answers for how often that happens?
Yeah, it should probably never happen that your whole cluster breaks and then you find one node to be more advanced than the other. All nodes should have the same exact data in, so Yeah, it should. Generally speaking, a well-configured Galera cluster should never have a most advanced node, but there is something called PC recovery, which basically means that in say a power failure, if everything goes away, Galera, when you start it, actually requires you to have one bootstrap node, and all the others are auto-discovered to join, but you don't have to re-bootstrap anything with PC recovery data inside a data file. But you should not have the situation where there is one more advanced node. That is more a master-slave, semi-synchronous kind of situation.
Okay, thank you. Last question. Out of curiosity, does Galera always, oh, wait, excuse me. Out of curiosity, does Galera always allow you to query against any node in the cluster?
Yes, they're all fully functional read-write nodes, so you can read and write to any of the nodes.
Okay. Does anyone else have any other questions? I'll look and see if there's any hands up. All right. Well, everyone, just to be mindful of our time, we're at the top of the hour, and I just want to tell everyone, any of the questions, if you have more questions, feel free to send them to marketing@idera.com, and we'll be glad to get back with you with any questions that you have. And we do appreciate you today spending your time with us, and we look forward to our next webinar. Y'all have a fantastic day. Thank you.